Bushy Park's triple SI status was its veteran trees. We've got 144 of them in our management programme, so this number will increase over time, certainly with some of the hawthorns and the like that we have here. And for the 144 trees, we have individual surveys carried out on them a minimum of every 5 years, and an individual management plan for each one of these veteran trees, okay, which we carry out over that 5-year period, which might be, for instance, as you can see here, we fenced this tree off because, of course, what we don't want to be doing with veteran trees is disturbing a lot of that ecology. So the particular environments which we're going to see as we go around today are crucial to the specific organisms that live and have adapted to live in those particular environments. So if we start cutting these off because we're worried they're going to fall on people's heads, we destroy those environments. So of course what we do now is we manage the target, okay, the target being you guys. So we fence the area off. What this does as well is protects the people from the tree. It also allows the ground to recover, so all of the beneficial soil organisms recover, the compaction diminishes, okay, and 50% of the tree, of course, is underground in its root system, in its ecology, in that soil environment as well, with all this mycorrhizal fungi that we'll talk about later on, also the symbiotic relationship it has with fungi and in the soil. So this is ideal for us, absolutely perfect. And it means that we don't have to start to mess about structurally with the tree because we're worried about it falling on people's heads. Interesting, we were talking again this morning about the stresses and strains on these particular trees as they age. We've only probably got a functioning third, maybe half of the root system on this tree. So again, the other half is dead, decaying, so there could be an issue with this tree toppling over. But also when we look around, if we look at the tree behind us, directly behind us, there's an example of a similar aged oak, full crown, very, very healthy. If we look to our right, or straight in front of us and to our right, we can see two oak trees which are struggling. And the way we can see that is if we look at the amount of sky that we can see through that particular oak tree, and then compare it to the one, again, that we looked at first of all. Can you see the density of the canopy, the amount of leaf area in that tree? There's a little bit of dead wood up there, we'd expect that, quite natural. These two trees here are struggling, particularly that one, which I can tell through many, many years of experience is suffering with a root issue. So there's something damaging the roots there. It's next to the gate, so it's probably a compaction issue. It's a soil compaction problem that has affected the roots in one way or another. We will look to alleviate that over time, but sometimes the disturbance is to a point where the tree goes into a terminal decline and sadly dies. That's just trees, unfortunately. So we do have to be very considerate about that. People pressure, particularly, and you can see that by the way we've moved the path round the pheasant tree now. So that path used to cut right underneath the big cedar that leant over the top of it, and of course we had the option of either pruning the cedar to stop it falling over on the path, or moving the path, which was the much more expensive option, but obviously benefited the tree much better. So we do monitor these, and again, with the health of these trees, there's things that we can do, decompaction work on the soils and the like, to try and bring the tree back from its declines. Yes, the cedar, probably 150 latest, I would have thought.
So it doesn't classify as being a veteran at that age?
No, it's interesting because, again, we go back to that, that veteran question. There's a veteran hawthorn just behind us, okay? So it's significant as to the species involved as well. If you think of birch trees, classically, nice silver birch, Okay, an old birch, a very, very old birch, is 80 to 100 years old. They don't live very long. They're pioneer species. They get in, they grow quick, they die quick. Okay, so we might classify a veteran birch at 75, 80 years old. That hawthorn's probably 150 years old. It's got veteran features. We're calling it veteran hawthorn, but it's not quite ancient. We do have examples of some nice ancients, and you can see we're starting to fence some of them off there where they're collapsing and regenerating. So yeah, the veteran and ancient tree is defined by the species, okay, the features, and these pre-slotted ages. 400-year-old is ancient for oak, but 150-year-old would be ancient for birch, or probably 100 actually, thinking about it. The thing with trees is is that if you can imagine that cylinder, the tree, a cylinder in cross section, the only actual living part of the tree is the very outside of that cylinder. Everything inside of that is either part of the functioning water transport system or actually what we call functioning deadwood. So it's actually inert, there's nothing going on in there biologically, it's just there to support the tree. So for it can't, so our expression is that trees seal, they don't heal. Okay, so there's no healing process within trees. All they can do is build new material from areas of meristematic growth, so areas that actively are growing. So you could, if you came back in 400 years' time and that tree was still healthy, have a much wider tree that has started to expand around that area of dead tissue. Yeah, very slow process. So we've got a casualty of Storm Eunice here. This was a lime tree, probably again 150, 175 years old. It's the casualty of what we call a heartwood decay, a basal heartwood decay. So fungi have been active within the central tissues of the tree in extreme weather conditions to fail. So the tree was almost split up through the middle there through the actions of this fungal decay. You can see that it's degraded the wood quite considerably to what it should be, but it was the effect really of the storm that has caused this tree to fall over. There's no way that we would have felled this tree because of the decay we would have identified as part of our inspection process. But they fall over. Yes, one of the things with trees, the object of the game is just not to be there when it does. And our job, the main part of our job as arboriculturists as well, is to assess these trees, identify these defects, and then try and guess how long we've got. We can do stuff to the tree, so we can carry out remedial works. We can reduce the tree in height. You'll see examples of this as we're going around. We can reduce the tree in height to reduce the lever arm, so the pressure the wind puts on the base of the tree. And we can basically monolith the tree if we believe that it's very, very close to failure. We can cut it down so it's just a stick. But we try, if it's in this sort of situation where we're looking at it and we're thinking not too many chances it's going to damage property or injure people, we will let them carry on and decline disgracefully. What they carry out is dividing the parks up into areas of occupation. So basically when we look at a park map, we think the areas, say the pheasant tree area in there is high occupancy, lots of people loitering around under my trees, being really annoying, okay, and at high risk of bits of trees falling out and injuring them. So there's zone 1 trees. Those trees are looked at every year, okay, come what may. And we're obviously a lot more cautious with those trees because of the potential for harm. We come outside, trees along paths like this, particularly along here, we would class as zone 2, so areas of moderate occupancy. So the chances of people being injured by pieces of tree falling off or whatever in these areas is lower than the pheasant tree, but not quite low enough. So again, we look at those trees every 2 years. The rest of the park, so the deer park that we're going to go to shortly, they're in a zone 3. So that could be anywhere from 3 to 5 years that we inspect. And again, we do send a step away and only action trees which we consider to be if over a desire line or something along those lines. Otherwise, we just let them break apart. There's a nice veteran alder behind us. And one of the things that we're going to look at later on with one of the oak trees as well is is the term that we use, growing downwards. You can see that the original tree itself, which was probably about 18 metres tall, has failed through decay. And then the basal part of the tree has regenerated, has reformed this much younger tree. So the tree itself is probably over 100 years old, but the actual basal part of the tree we're looking at there is maybe 30 or 40 years old. So it's reinitiated from these areas of active meristematic tissue much lower down in the tree, forming this quite squat example, and very, very resilient as well. Nice habitat again, those holes, the cavities in there for bird nesting, bats in particular, microorganisms, types of saproxylic insects. And again, very, very resilient now in its squat short form. It's not going to be so exposed to storm winds and everything. Another 100 years easy. There's 2 types of deadwood habitat. So we've got, like the monolith there, with the standing deadwood. So very dry, very desiccated wood. So the niche fungi and organisms that break that down are specialists in that environment. Then this timber will be decayed by other niche type fungi. It'll be much more moist, it'll be a much wetter environment. Fungi are incredibly competitive, so they're very aggressive against each other, so there'll be this massive bun fight going on in there. There'll be very, very little of it remaining. Lime decays quite quickly, so if you think of the crocodile oak by the bridge in the garden there, somebody was saying to me earlier on that they got a picture of their daughter who's now like in her 20s or something, sitting in the jaws. So this will decay much, much quicker, but also something we'll talk about as well is the fact that the fungi don't necessarily just come in from the air, from spores from the air. They are actually already in the wood as endophytic spores. So they've been taken in by the tree. As the tree's grown, these fungi spores have been absorbed, and they sit quite quietly, just biding their time inside the tree. The environment's not good for them to grow, waiting for something to happen. So lightning strike, things like that, wood starts to dry out, the fungi become active and start to decay. So they're in there already. So yes, the school of thought very much now is the ecological value of leaving it absolutely untouched if you can. It's the classic, clean woods. We've got to clean it all up, tidy it all up, burn it all. And what they realised is that areas of woodland that had just been left regenerated so much faster than the areas of woodland that had been cleared out through. And of course were exposed to sunlight that they'd never seen for decades and decades. Whereas the other ones, the trees just regenerated and the decaying wood benefited all of this new regen. Yeah. So we very much now leave as much as we can. Okay, let's head that way. On Chestnut Avenue, you'll see trees covered in flowers, and then next door, no flowers whatsoever. They haven't got the energy anymore to make the flowers, to create the flowers, to produce flowers. They're just limited to putting out enough leaf to get it through the year for next year. Now, we have spent at least 8 years arguing about what we're going to replace the avenue with. So the horse chestnuts aren't viable. There's no stock that we could buy that was resistant to the bacterial canker. And again, we talked about this morning, there's no incentive to research the genetic viability of canker-resistant horse chestnut, because the amount of investment it would take to carry out that research, the time period might be 30, 40 years. Cost benefits of that investment would be minimal from the amount of money you would make selling these. And in my opinion, I think in the UK we will see pretty much the extinction of horse chestnut as a parkland tree within the next 75 years, because the decline's quite slow, but there are very, very few trees which are showing any kind of resistance to this. We've looked at various replacements for it. We've also discussed whether just to let the avenue dissolve into nothing, so once all the horse chestnuts are gone, not replacing it, because of course we have the 4 lines of limes on the inside. Do we necessarily need another line of trees on the outside? Historically, it's called Chestnut Avenue, so there is certainly the incentive. We've thought about sweet chestnut, so Castanea sativa, so we thought about that, but unfortunately there's a number of diseases which that tree suffers from, which don't make it a secure tree to plant for the future. And another row of limes would just be so boring. That currently is one of the few trees which doesn't have a massive amount of potential pathogens that would affect it into the future. One of the things we need to think about of trees as being whole organisms is the fact that their resistance to pathogens and their active resistance, so their ability to fight pathogens off, is energy driven. So it's not an inert thing, it requires energy. So the photosynthesis creates the wood, the amino acids, all of the polyphenolic compounds which they use to fight the particular pathogens. So the less energy the tree has, the less ability it has to fight pathogens. So air pollution, particularly nitrous type air pollution, nitrous oxide type air pollutions. There's factors like dog urine, which when you think about it on the whole is a bit of dog wee, so what? But of course worming tablets and things contain a lot of chemicals which are severely affecting soil fauna. So the mycorrhizas, the fungal, bacterial and other communities in the soil are being affected by these chemicals from dog worming tablets. And I know it sounds so if the trees are stressed physiologically by drought in particular, and I think you'll all agree that how much, if we think to the beginning of March to now, how much rain have we seen in the last 2 months? Very, very little. And this is the time of year those trees are drawing up huge amounts of water from the soil, and if it's not being replaced, they're going to be stressed out straight off the bat. So that physical stress, the genetic stress, then lack of ability to cope with the pathogen means that they're in terminal decline, unfortunately. So when we formulate our tree strategies, we generally have a 10-year action plan, a 25-year management plan, and a 100-year speculative plan. Nobody's going to be around in 100 years, even if I was one, probably, when we wrote it. But so with the 10-year one, we can pretty much look at the climate dynamics now and go, right, it's going to get warmer, it's going to get wetter, blah, blah, blah. The 25-year one, nobody's got any idea, have they? As somebody said this morning, she said, well, if the Gulf Stream breaks, then we're going to be plunged into this next ice age. And then you get the other people that are saying, no, I mean, it's going to be tornadoes and hurricanes and all sorts. So it's very difficult to write these management plans when the information is cumulative over time, and still not very accurate. There's definitely climate change occurring, and as I said, I think probably the last 7 or 8 years, every spring has been dry, and that's just not normal. and it makes it very difficult to establish young trees as well. That's one of the problems. The older trees can struggle along okay. That's depressing. Let's talk about some good things. So this is one of our veteran limes, and we can see the top of it. We've lost the top. The top's actually down there on the ground. So that's the upper half of the tree. The lower half of the tree, very much like the older tree that we looked at earlier on, okay, is growing downwards. So the bottom half of the tree now has responded. It's produced this magnificent new crown, which is half the size of the original tree, and it's going splendidly. It's very, very healthy. Again, nice canopy density to it, nice colour to the leaves. It's probably decayed, extensively decayed in the centre of the tree, but the rest of the trees responded wonderfully to the top breaking out, and also something called the body language as well. So can you see these sections running down through the tree? And these are effectively the tree breaking itself up into these linear functional units. And what this means is that rather than it being a continuous cylinder of living tissue, it's these very small horseshoe-shaped areas of living tissue which function as a whole. They're all part of the one tree, but they are much better adapted with these much larger trunks and these much less, like I said, more stressful lower branches. So when you see this shape, in particular, this rib, if you think in engineering terms, this is very, very strong. It's the tree reacting to that lower branch now being secondary into a primary branch. So it was originally a secondary branch, it's now a primary branch. It now has its own functioning unit as well. So even if the rest of the tree died, that functioning unit could well survive. And there are examples, if we were to walk all the way up to the other end, of these trees where you'll see that, where there's sections of the tree missing and just that one functional unit left. And yeah, very, very fascinating. So this is what we say when we're inspecting the trees. We're looking at this body language, and when we see these adaptations, we see the tree responding to the forces, to the actual structure of the tree, and that's good. So that's a good sign that the tree is healthy and it's managing its own structural changes. But we can speculate. So I would say that this is 18th century, so I'd reckon on around 200 years old, roughly. But we don't actually know. But we're going to measure a tree in a minute, so we shall have a go at saying how old it is. We were talking earlier on about ages and relevance of veterans and ancient veterans and the like, and it's just interesting really to look at people's perception of how old trees are, and what I'd like you to do is have a look at this particular tree here and think to yourself, well, how old is this tree? Let's just say that. And what we'll do is we'll use a method of measuring this tree and its circumference, and we'll be able to work out how old this tree is. Not massively accurate, but accurate enough. So the circumference is 460 centimetres. So the girth of the tree, 460 centimetres. Now, who's got a smartphone with a calculator on it? So it's 460 centimetres divided by 1.88. What have we got? 250. Right, so yeah, 250 years old. Very good, very good. Yeah. As we know, oak timber is incredibly valuable. It's dense, okay, it's long lasting, it's hard. It's the timber of choice for furniture, for doors, for pretty much everything. And the reason for that is it grows very slowly. It lays down a lot of material, a lot of lignin, a lot of cellulose to make that wood up. And of course, because it's so dense, the materials required the cellulose, the lignin required is all generated by this photosynthesis going on in the canopy. It's incredibly expensive to the tree to make wood. So with oak trees, when you see a tree of this size, 250 years, okay, that's a good age for a tree, but it's still quite young for this tree. We've got examples in this country 1,000 years old. So 250, it's a quarter of the way there. The growth of these trees, 1.88 centimetres per year in circumference, is relatively small. But yeah, nice example. Thank you, people, for that. It's just a good demonstration that they are perhaps not as old as you think, but certainly getting on. And as I said this morning, it's thought the roots of it being called Bushy Park is because of the hawthorns. And we certainly got maps going back to the 16th century with definite hawthorn in this area. So yeah, these might not all be 16th century trees, but it is certainly very strange to see so many hawthorns planted out in what is wood pasture. We started putting rings of timber around the trees as well, and it's a sort of soft way of saying bugger off. Okay, it's a soft way of saying just don't go under these trees. So we can't fence everywhere, so we try to utilise the dead wood just to, yeah, perhaps, I mean, of course, people just, it's now a seat, so now people go and sit on it. But the dead wood, again, all of the organisms that are adapted to break this type of wood down are very distinct, okay, and very niche organisms. Whatever killed this tree, no idea. Could have been lightning because it's right out in the open. But it was suffering with something we call brown rot even before it died. So the actual inert contents of the tree, the heartwood of the tree, were being broken down by a fungus called chicken of the woods. Has anybody come across this? And chicken of the woods, big bright orange yellow bracket on oak trees this time of year through to the autumn, and it's a voracious consumer of oak heartwood, and it's called what we call a brown cubical decay. It breaks the wood up, can you see, into these small sort of very cubical sections, which are just basically incredibly brittle and just turns to dust in my fingers. So as a structural component, once the fungi has had its wicked way with this wood and created this brown cubical rot, it's lost any kind of strength, supportive strength, to hold the tree up. So wood itself, the two main components of it, without going into massive detail, is cellulose and lignin. And if you think of lignin as being the concrete and the cellulose as being the reinforcing rods within concrete, so the lignin takes that gives that compressive strength, so it holds the tree, the wood, all that weight up, and the cellulose gives it the flexibility, the ability of the wood to move, okay, in the winds and the like. So if the fungi comes along, they are effectively specialists. Some of them dissolve the cellulose, or they eat the cellulose. Some of them eat the lignin, or they just eat the cellulose, they eat the lignin, and then some of them, the really crafty ones, eat both at the same time. So the ones that eat both create a white rot. And what that does, of course, if you take the lignin out of the wood starts to basically sink on itself. And then you start to get these trees with very swollen bases where the tree's compensating. Basically, it's all my middle's going. So it starts to produce more wood at the base. The more frightening ones are the ones that take out the cellulose and leave the lignin, because the tree doesn't respond to those visually. It just snaps. Okay, so things like the Latioporus will just cause the trees to basically fail very, very rapidly, because it's a brittle decay rather than the lignin going, leaving the cellulose, which is a very flexible, wobbly decay, and is more visually apparent to us as in when we're inspecting trees. So now these are down, as I said, this outside of the tree now is so dry, exposed to the the day temperatures. The environment in there is pretty much barren of anything. There's very few organisms that will break that wood down, so it might last easily another 100 years. So it'll just be weathering really that starts to break that up. But within the tree, where there's more condensatory moisture and things, there'll still be fungi active in there. You've got the flaking bark as well, which is fantastic summer roost bat habitat. So your bats that fly around during the day, during the evening and nights, eating the insects. Then during the day, they pop underneath these pieces of flaking bark, okay, and spend the day having a snooze, digesting all their lovely flies. So these kind of monoliths, as we call them, the little cavities, the flaking bark, all of these niches and nooks and crannies are ideal environments for insects that are hiding away and resting. The bats, as I say, taking a little snooze. And again, the standing wood is a different environment to the wood on the ground, but most of the edible things, edible parts of this particular piece have gone now. So we've got a lovely oak tree behind us. Again, nice example of an open grown. You can see this tree's been has open grown for its whole life. So if you think about forest trees, there's always competition trees next door growing up, causing the shape of the tree to be long, very linear, whereas these ones, they've just gone poof. One of the consequences of that is that you get these very heavy lower limbs on the trees. What we can see at the base of the tree, there's two fruiting bodies. Can you see the two fungal fruiting bodies? The two brown blobs at the base of the tree with white undersides? Yes, so that's that particular fungi is Ganoderma. It's a heartwood decay, quite common on oak, and the fruit bodies are perennial, so they last year round. Quite a lot of fungal fruit bodies appear in, let's say, the autumn primarily, spore for a month or two and then disappear. So as a tree surveyor, that's really annoying. But these ones, they're perfect because they're there year round. And of course what that does is allow us to go, okay, I know what's going on in there now. So these principally decay away that static mass of the tree. So the heartwood of the tree, that wood that I said was non-functional in the centre there, and really does depend on the health of the tree and the environmental conditions as well. So the amount of tree stress the tree's under as to how quickly these fungi can decay away that centre of the tree and start to cause instability. And again, if you look at the base of that tree, can you see how flared it's starting to get at the very base? So it is reacting, it's starting to adapt to that basal decay, and as long as it stays healthy, which again, canopy density of it's really nice healthy canopy colour, it's probably going to maintain a decent or respectful distance between its capable structural wood and the compromised structural wood at the base. The limb loss is a bit shame because it's probably more to do with summer branch drop, which is a phenomenon which we get particularly in oak trees and horse chestnut as well, is after protracted periods of drought. So if we say 4 to 6 weeks, like about now, 4 to 6 weeks of very little rain, then the tissue in the wood, okay, has lost so much moisture, it's become very inflexible. It's lost that flex, it's very brittle. And where the branches, of course, they're cantilever structures, so the whole weight carrying point of the branch is where it connects into the trunk of the tree. So if those tissues are starting to become desiccated, they're starting to become brittle, what happens is, oddly, we have the drought's broken with a sudden downfall of rain, and this influx of water, the weight of the water on the foliage, the brittle nature of the timber, okay, before the influx of water re-moistens the timber, causes this phenomenon we call summer branch drop. Completely unaccessible from a point of view of a tree inspector. We just know which trees basically are susceptible to summer branch drop. We put these fences around, and that is why we don't recommend with mature trees you spend any time underneath them if you value your head, because they can shed these branches very unexpectedly. On a day like today with not a breath of wind, bang, these branches come out. It's left quite a sizable wound. Somebody asked me this morning as to whether that's going to affect the tree, and there is certainly a change in the wind dynamics for the canopy of this tree now, because it's obviously grown as one unit, and now one part of that unit has fallen off, exposing the other parts of the tree to wind stresses which they probably wouldn't have had beforehand. But it's of limited concern. We've got the fence around it. That should keep people out. So if it does decide to drop any more branches, then we've got it covered on a risk management basis. So what we're going to do is we're going to head basically towards the pond. We'll go up the Lion Gate end of the pond, cross over the road, and that we'll have a look at the final group of oaks up there. This tree, the upper half of the canopy, still functioning twigs and branches up there, but it's diminishing, whereas the lower part of this crown, which is actually reforming into a crown shape as well, is what we call reiteration. So this growing downwards, the tree downsizing now that it's reached that age where it doesn't need to maintain such a large crown. It doesn't have to push the water up so high into the upper crown of the tree. It wants to basically get rid of all that, become what we classically think of with veteran ancient trees, is this big squat, okay, tree in the landscape, and this is fulfilling those features perfectly, and it's compensating for its age wonderfully, and again, you know, this could go on for another 200 years quite happily with its downsized shape and form. Now you can look at these trees and you can look at the veteran features of this tree. Okay, how many cavities can we see up there? How many holes? I mean, there's dozens. There's flaking bark, there's cavities, there's this distinct sort of habitat you get up in the upper sections of those trees there, which are little niches which the insects can hibernate in quite safely. The bats can hang out there during the day in the summer, and it's perfect, absolutely perfect. It actually ticks so many veteran tree boxes. This could be your perfect example of an ancient veteran tree. Really nice nesting habitat for birds, for maternity roosts for the bats as well. Nice bits of storm damage up there, particularly good. So again, another wonderful veteran tree. You see the burr at the base of the tree. Somebody asked me about that on this morning's walk, and again, these are quite typical on oak trees. They're either viral or they can be bacterial, and it's a stimulus of meristematic material. Meristematic material being the cells that can effectively reproduce, can grow more cells, and very often these burrs are covered in dormant buds, so they can be very effective defense mechanisms. If the tree's ripped apart, these burrs sprout into growth and they can extend the life of the tree even further, and quite often, like this one in particular, they're inert. So there's some stimuli in there that's making the meristematic tissues reproduce but not actually growing outwards. So they're just growing a bit more wood each year, and wood turners absolutely love these because the tissue inside of there is all folded over on itself, it's knitted together, full of these lovely disappearing concentric circles, and yeah, so very, very valuable. We have had examples in Richmond Park of people coming in at night and sawing some of them off.
No.
Oh yeah, yeah. Cheeky monkeys.
Have you seen there's obviously a bee's nest up there as well?
Is there?
Yeah, can you see it in the hole just above
yes, on the end there.
Did you spot that, David?
Yeah. So there's so that's a wild bee colony up there. And, that's about it, I think. So yeah, so there you go, veteran trees of Bushy Park.